So oxidation numbers. These numbers are actually the charges that atoms form when they lose or gain their valence electrons. So let's do 1 plus, 2 plus, 3 plus, 4 plus. So you'll notice, let's say in nitrogen, its oxidation number is 3 minus because it gains 3 electrons. Bromine, Br, it's 1 minus because it's going to gain 1 electron to behave like a noble gas for it to be stable. Let's see. This magnesium, it's going to be 2 plus oxidation number because it's going to lose 2 electrons to behave like neon. So beryllium is 2 plus, oxygen is 2 minus, hydrogen is 1 plus, helium is 0 because it doesn't have to gain or lose electrons to be stable, as will argon. Lithium is 1 plus, nitrogen is 3 minus, chlorine is 1 minus, aluminum is 3 plus, and phosphorus is 3 minus. So what happens in an ionic bond? What they do is that metals are going to actually lose their valence electrons to form a full octet, because in losing its valence electron, sodium behaves like neon. What chlorine is going to do is going to steal or gain the electron from, let's say, sodium, and in turn, it's going to have its own full octet, and it's going to form a 1 minus charge because it gains 1 electron. So what happens with this, when opposites attract, so to speak, you have this electrostatic attraction between the positive and negative charge, and that's going to form a stable compound. So sodium plus chlorine, they will make sodium ions and chloride ions, and they're going to form a table salt, a stable compound, sodium chloride. So will these ions make compounds? So because they have the same charge, these will not. Plus 1, 2 minus, yes, because they're opposite charges. Calcium ion and fluoride ion, yes. Oxygen ion and chloride ion, no. Potassium and lithium, will these make ionic compounds? No, because these are both metals. Ionic compounds, beryllium and chlorine, yes. Aluminum and fluorine, yes. Iron and oxygen, yes. So this is talking about something called the crisscross method, or that I like to use a crisscross method or oxidation number method, and how we're going to make our ionic compounds. So you'll notice that you have your symbols with the oxidation numbers on the top. You crisscross just the numbers and ignore the symbols. You forget about them. Don't even write them down again. Lithium, you crisscross the 1 over to the oxygen, but because it's 1, you can drop it. Over here, you'll notice that you have calcium 2 plus and O2 minus. Crisscross the 2's, but since they're the same number here, that you crisscross those oxidation numbers, those can reduce. So aluminum and chlorine. So you have a 1 minus charge on chlorine and a 3 plus charge or oxidation number. So you're going to crisscross those numbers. So aluminum is 1 and chlorine is 3. Sodium is 1 plus ion and sulfur is a 2 minus ion. So I'm going to crisscross the 2 for the Na2, and the 1 from the sodium, or the implied 1, is going to come down to the S. Oops. There we go. Using dot diagrams. So let's make this sodium and do iodine. That's fine. So using dot diagrams, think of them as puzzles, like how it's going to fit. So lithium has 1 plus. It has a 1 dot, while nitrogen has a total of 5. So I'm going to steal this 1, but notice that I still have 2 open spots for my full octet. So lithium has a 1 plus charge, but what do I got to do? If these are the only 2 elements in this compound, I got to recruit more lithium to kind of fill in those empty spots, if you will, on that nitrogen. So I'm going to steal this one here. I'm going to steal this one. So now nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. I gained 3 electrons, so my oxidation number is 3 minus. So for the final count, if you will, for the ionic compound, you have 3 lithiums and 1 nitrogen. There is your ionic compound. Oops, I can't read that. Li3N. Calcium is 2 plus, oh sorry, no, that's the wrong one. So calcium has 2 dots, oxygen has 6. So what oxygen will do, it will steal these 2 electrons. Calcium lost 2 electrons, so it's 2 plus. Oxygen gained 2 electrons, so it's 2 minus. Those are the charges it formed. So notice how oxygen now has a total of 8 valence electrons. Calcium has no more because they were stolen. So I'm good to go. So calcium, it's CaO. Aluminum and chlorine. So aluminum has 3 dots, while chlorine has a total of 7. Aluminum is going to steal this one, and so chlorine now has 8, so it gained 1 electron, so it's 1 minus. However, you don't want free electrons like this, because those are very reactive, and therefore the compound will not be stable. So I have to add 2 more chlorines to get rid of those 2 electrons that are on that aluminum. So I'm going to steal this and steal that. Chlorines gain those 1 electron each, so it's 1 minus. Aluminum lost 3 electrons, so it's 3 plus. So the compound of this, it's like before, AlCl3. Sodium and iodine. Sodium is 1 plus and has 1 valence electron. Iodine has a total of 7 valence electrons. So iodine is going to steal this one because I forgot to mention this, whichever element is going to steal the electrons, it's the more electronegative. It's going to want to attract an electron. Kind of like how we discussed with periodic trends. Just forgot to mention that. Iodine gains an electron, so it's 1 electron it lost. It gained. Sodium lost 1. So now that's 1 plus. I am content with my full octet on my iodine, so my compound is NaI.